Yeah, I think we have the number that we require. So for this question, this is a question of series circuit. And you are told to find the total resistance, total current, the R2, R1, the R3, and R4. Then again, the I2 said, what is the meaning of instantaneous voltage and instantaneous current? And write the equation of instantaneous current. Then this one says converts the angular displacement in radian to degree, and this one to radian. So for question number 4I, we have our known variables, and the known variables are 48 volts, R1, 48 volts is total voltage, R1 is 250 volts, 250 ohms, sorry. R2 is 350 ohms, R3, 475 ohms, R4 is 570 ohms, while R5 is 685 ohms. And you are supposed to find the total resistance, the total current, the voltage drop at R1, R2, R3, and R4. And we record our Ohm's law, which states that the total current flowing through a circuit is directly proportional to the total voltage and inversely proportional to the total resistance of that circuit. And we recall that our total resistance in a series circuit is R1 plus R2 plus R3, and so on and so forth. Then for voltage drop across R1, will now be the total current times by R1. So I've given the basic equations, like the three basic equations. So for us to get the total resistance here, we will now say that R1 plus R2 plus R3 and so on and so forth, we have up to R5. This is why I stated this here, up to R5. And we fix our variables to give us 250 ohms plus 350 ohms plus 475 plus 570 ohms plus 685 ohms. That will give us 2,330 ohms. So our total resistance is 2,330 ohms. Then from equation 1, this is the equation 1, we will have that our total current is equals to total voltage over total resistance. And that will give us 48 volts over 2,330 ohms, which is equals to 0.02060 ampere. And we can say it's 20.60 milliampere. So this is our total current. For the voltage drop across VR1, we recall this our equation here. This is I3. For VR1, the total current, which is 0.02060 times 250 ohms, and that gives us 5.15 ohm. 5.15 ohm. Then for VR2, the same thing, 0.02060 ampere times 350, and that gives us 7.21 volts. For VR3, we have that 0.02060 ampere times 475, and that gives us 9.785 volts. For VR4, 0.02060 ampere times 570 gives us 11.742 volts. Then for VR5, 0.02060 ampere times 685 ohms, and gives us 14.11 ohms. If you sum them together, that will give you the total voltage, which is 48 volts. Then for 4II, say instantaneous voltage is the voltage of a sinusoidal signal at an instant of a time. Like at a particular time, T1 or T2, you have a particular voltage at that particular instance, and it changes as the time changes. So we can say that instantaneous voltage is the voltage of a sinusoidal signal that changes in accordance with the time at that moment. The same applies to instantaneous current, is the current of a sinusoidal signal at an instant of time. So we can say that instantaneous current is the current at an instant of time, at a particular time in a sinusoidal signal. And the equation of instantaneous current is small I is equals to capital I of M sine omega t, or small I equals to capital I sine alpha. And this alpha can be our theta, which is the angle that we know. Okay. So for this other one, we talked about the angular displacement conversion, which is for II. Say convert this radian to degree. Convert radian to degree. And this is the formula for converting radian to degree. If you want to get degree, you say 180 degree over pi times radian over 1. This applies to biomedical and P&O. So at pi rad, we have that the degree will be equals to 180 over pi times pi over 1, because the radian we are looking for is pi. So we will now say that 180 we will now say that pi divided by pi will give us 1, and the answer is 180. For 3 pi rad, we have that 180 over pi times 3 pi over 1, which is, when you divide pi, we will now have 3 times 180, which is 540 degree. For 3 pi over 4, 180 over pi times 3 pi over 4. Pi will cancel out, 4 will divide 180, and when 4 divide 180 becomes 45. 45 times by 3 is 135. So why I'm showing you all these things is that it applies to, the formula applies to everything, and you can see that even 5 pi over 1, we have it at 900 degree. And this explains why we say that the sinusoidal signal is a repetitive signal. It completes one cycle and it continues, creating more harmonics. It does not stop. So converting this degree to radian, this becomes our formula. We have pi over 180 times degree over 1. And that's, hold on. And that will give us, we have 15 degree, which will be pi over 180 times 15 degree. And our answer is pi over 15 degree. You can further subdivide this thing by converting pi, which is 3.142 or 3.143, as the case may be. 3.143 divided by 15, you just write it. But I'm leaving it at fraction, mostly at fraction. So we have 38 degree to give us 19 over 90 rad, or 0.2111 rad. We have 275, and 275 gave us one whole number, 19 over 36 rad, which is 1.5278 radian. We still have 850 radian, which is 4 over 13 over 18 rad. So this is what your calculator can easily do. Are you following me? You just need to know this formula and how you apply the formula. Then for question number 5, what is the magnetic permeability of these materials whose relative permeability are 3.6 pi times 10 raised to the power minus 9 Weber per ammeter. Then the same applies to 1.2 pi times 10 raised to the power minus 14 Weber per ammeter. And 2.8 pi times 10 raised to the power minus 5 Weber per ammeter. Then they further asked you to categorize this material into diamagnetic, paramagnetic, and ferromagnetic material. And they gave you the permeability of free space to be 4 pi times 10 raised to the power minus 7. The II of that question said, define the slip ratio of electric motor and state its formula. Find the frequency of 12-pole synchronous motor rotating at the speed of 1,800 RPM. Then III states the difference between electric motor and electric generator and write their slip ratio. So for question number 5I, this is material 1, and relative permeability of material 1 is 3.6 pi times 10 raised to the power minus 9. For material 2, 1.2 pi times 10 raised to the power minus 14. For material 3, 2.8 pi times 10 raised to the power minus 5. And the relative permeability is equals to permeability of material divided by permeability of free space. And we know the permeability of our materials. So for material 1, we have that the relative permeability of that material the permeability of the material will now be 3.6 pi times 10 raised to the power minus 9 times 4 pi times 10 raised to the power minus 7, and we are having 142.122 times 10 raised to the power minus 16 Weber. I hope you are following. And this is the formula for relative permeability of materials. This is the formula for relative permeability of materials. So what you are supposed to do is to use this relative permeability, which is permeability of material divided by permeability of free space, to determine this material permeability. For the first one, the material 1, the permeability of material 1 is 3.6 pi times 10 raised to the power minus 9, which is this. And when you make this subject of formula, this is the simplified equation here. When you make it subject of formula, permeability of material will be relative permeability times permeability of free space. And this is what we did for material 1, material 2, material 3. And that gave us 142.122 times 10 raised to the power minus 16. So, and the same applies to the relative permeability for material 2. We have 47.3741 times 10 raised to the power minus 21. For material 3, we have it at 110.5396 times 10 raised to the power minus 12. And it said they should categorize the materials. You can see that these materials are very poor in the relative permeability of free space. And from what we have, you can say that all these materials are diamagnetic materials. Are you following me? They are diamagnetic material because the permeability of free space, which is raised to power, this is permeability of free space, 4 pi times 10 raised to power minus 7. So our values are less than the permeability of free space. So that's why for diamagnetic material, it sticks good. For para and ferro, we just cancel it. So the slip ratio of electric motor. That's the difference between the stator motor and the speed of the, is the ratio of rotor to stator of a speed of electric motor, where the stator is ns and the rotor is nr. So the difference in the stator and rotor all over the stator gives us the slip ratio of electric motor. And for electric motor, the slip ratio is usually positive. Then for electric generator, the slip ratio is negative. Using the electric motor speed equation, F equals to ns over 120 degree. And from there, we have the number of poles 12. We have the speed 1,800 RPM. Then our frequency is what we are looking for. We now have 120 poles times 1,800 RPM over 120. So what we have is 180 Hz. So our frequency is 180 Hz. The difference between electric motor and generator converts electric energy to mechanical energy, converts mechanical energy to electric energy. That is for electric generator. It converts mechanical energy to electric energy. For motor, it converts converts electric energy to mechanical energy. Electric motor has a positive slip ratio, while the generator has a negative slip ratio. And this is question number 6. This question number 6, those in P&O and biomed should pay very close attention on how we are going to solve it. So this question is solely for you people, and part of it, which is P for P&O. So said, taking the phase angle of figure 4, this is the figure here. Figure 4 sec is to be 0. This is the phase angle, which is this 0 degree. Calculate the inductance, capacitance, and impedance of this circuit. Find the total current I of t and write if the current is leading or lagging. What is the apparent power S, reactive power Q, and real power S? Real power is W. Don't mind this S, please. Real power is measured in watts, which is W, please. Then this circuit power factor PF, and write the reason if this circuit has a good power factor. Then the B, what is the magnetic flux of a magnetic circuit whose reluctance is 150 amp turn per Weber and magnetic force 240 80 amp per turn. Sorry, amp turn, not per turn. So for question 6a, this is our voltage, which is 240 volts at an angle of 0 degree by 50 Hz. Then our R is 80 ohms. Our inductor is 150 millihenry, which is equal to 0.15 Henry. Our capacitor is 50 microfarad, which is equals to 0.00005 farad. Then the frequency is 50 Hz. We are told to find the inductance, capacitance, total currents, impedance, real power, reactive power of, okay, the total reactive power and the apparent power. Then, please, for those of you in tech, if people will know this better, Chibuike, ask your question. Chibuike, ask your question. The person that raised his hand should ask this question. Okay, since he's not asking, this is the formula for impedance. The formula for impedance, which is, this thing is going to end in 10 minutes. Let me quickly round it up. Then we join another class for question and answer. This is the formula for impedance, which is R plus brackets, the reactance of inductor minus the reactance of capacitor. But for the reactance of an inductor, we have it to be 2 pi FL, which is 2 times pi times 50 Hz times 0.15 Henry. And that gives us 47.1239 ohms. Then for the reactance of capacitor, which is capacitance, is 1 over 2 pi FC, which is 1 over 2 times pi times 50 Hz times 0.00005 farad. And we have it at 63.6620 ohms. Then using this formula, substituting what we have that R is 80 ohms, and we have that the JXL is 47.1239. JX of C is 63.662 ohms. So when we substitute this, we have that the impedance is 80 ohms minus J 16.5381. This minus shows you that the circuit is capacitive circuit. Are you following me? It shows that the circuit is a capacitive circuit. And resolving the impedance using the, I think when I finish, I'm going to draw this. I will solve this one and draw it on the Cartesian diagram post on the platform. Resolving the impedance, we have that Z equals to square root of R square plus J minus X all over, JXL minus JXC all square. And we have it to be 80 square plus minus 16.5381 square. And we have our total answer to be 6,673.4095 ohms. And taking the square root is giving us 81.6890 ohms. And this becomes our impedance in polar form. Becomes our impedance in polar form. Then theta, the theta we are going to look for, we say that the theta is tan inverse of 16.5381 over 80. And our angle will give us 11.6786. Then this is our impedance in polar form. We have to put this angle and put this sign, which is negative. Then the total current will now be V of T divided by Z, 240 volts at an angle of 0 degree over 80.6890 at an angle of minus 11.6786. So means that we have our current to be 2.9380 at an angle of 11.678. So you will notice that this angle changed to positive here because this angle, when it crosses over to the numerator, becomes positive. Then the current is leading voltage by 11.6786 volts when you are plotting it as a sinusoidal wave. So apparent power is equals to S I T square times impedance. I of T total current square times impedance, and we have it to be 2.8980 square times 81.6890. And that gives us 705.1267. Those of you in dental tech, I think I gave you so many formulas on how to resolve this. Yeah? Pian and Biomed, you should ask them for their notes on this. Are you following me? Because I took my time to even draw the Cartesian diagram for them. Then reactive power will now be JQ of L equals to I square times the impedance, that is the change in impedance, this 16. The reactance of these reactive elements, which is 16, and we have it to be 42.7543 VA, voltage ampere reactive. For the apparent power is called voltage ampere. Then for the real power is I square times resistance, which will give us 690.5472. Then for the power factor, which is cos theta, which is equals to real power P over apparent power. And our power factor is cos 11.6786, which is 0.9793, or we say 690.5475 divided by 705.1267. And that gives us 0.9793. Please, power factor does not have a sign. It does not have a sign. You just put it, it does not have any SI units. Then for the power factor is a good one, and the circuit is a good circuit. The minimum a power factor can go is 0.85. So anything above 0.85 means that the circuit is a good circuit. Then for 6B, we have a magnetic flux, the reluctance, and we have a magnetomotive force, which is 240 all over 150. And we have 1.6 Weber as our answer. I think this is the last part of it, but I try to do one or two things here for those of you that missed the last class, the last physical class. Why is transformer rated in voltage ampere? Transformer rating does not depend in the power factor of the transformer. Rather, it depends on, one, the transformer copper loss and the transformer iron core loss. For the copper loss of transformer, it depends on the currents. And this is the formula for transformer copper loss, I square R. Then for the transformer core loss, it depends on the voltage. Yeah. And these core loss are in two sections. We have the eddy currents loss and we have the hysteresis loss. And this is the power loss for the hysteresis, which is the Steinmann's constant and the magnetic density, the frequency, and the volume of this core, the volume of the core material. So this is just like a simple question I try to solve here. What is the hysteresis loss of a transformer with Steinmetz constant of 0.02 Web if the core volume is 0.004 meter cube, magnetic flux density 0.5 Weber per meter, and frequency of 75 Hz. You state the formula, you fix in this, and we have the answer 0.002 times 0.05 times 75 Hz times 0.004 meter, and we have it at 30 microwatts. This is the core loss for that transformer. This is the core loss for the transformer. Another question is, what is the magnetic flux density of a transformer with rated core loss of 60 milliwatts, core volume of 0.005 meter cube, and frequency of 50 Hz? Take the Steinmetz constant to be 0.003. So we fixing this, stating our equation. We have that the B is 800 Weber per meter square, and we have the answer to be 800 Tesla. So this is our answer to the revision. If you have any question, you speak up, or you compile your question. I will share another link because this one